to do today was to do an instruction video as opposed to a correction video. So I have gone through some of these rate of change problems, the first three, question 1, 2, 3, and I wanted to do this to make sure that you are happy and comfortable going through the rest of them that I'm going to ask you to do in another little while. So as I said, we got question 1, 2, 3 done. These are from page 254 of your textbook. And we'll run through these, and then I'll post this up with the work for today, and we'll see how we go from there. So fingers crossed you'll be able to give these a good attempt after looking at these instruction examples. So we've got a loaf of bread just been taken out of the oven and is cooling off before being eaten. The temperature of the bread, which is measured in degrees Celsius, is a function of time, which is in minutes. It's saying the length of time the bread has been out of the oven. Okay, so that's what T is representing. So therefore we have T is equal to FT, capital T and small t. So I've got that written there, and what we're saying that is the first bit is temperature. Okay, is a function of time. All right, so the thing to think about here is that we have this happening. The temperature is changing. Okay, the temperature is changing because of time. And generally I would hope we'd be able to figure out or able to have a think about that as the time gets longer that the bread is out of the oven, the temperature is going to go down. So first part that asks, what is the meaning of F5? Okay, so F5 is the function of the temperature after 5 minutes. So we're substituting in 5 for the small t, which represents time in minutes. So that's what we're saying there. It's the temperature of the bread after 5 minutes. It'll tell us how hot the bread is, or what the temperature of the bread is after it's been sitting out of the oven for 5 minutes. All right. The next bit then is F prime of t, positive or negative. So the prime of t represents the rate of change. And that's what all of these problems are about. Now, we've done a couple of these before. If you remember, we looked at the cone filling up with water at different levels, or we looked at the vase that had a shape like that, and we looked at how the rate of change goes. So when we're looking at F prime of t, as I've written here, we're differentiating temperature with respect to time. Okay, so we're looking at the change in temperature based on time. So the idea is to talk through these and to explain it and to think about it yourself. So I've written it all out. Now this is what's literally being expected for your answer, but I've written it, as you can see, as time goes on, the temperature is decreasing, and that's the thing to keep in mind. What is actually happening here? I've taken this bread out of the oven. After a minute, it's going to be a certain temperature. After 2 minutes, it's going to be a lower temperature. After 3 minutes, it's going to go lower and lower and lower. The temperature is dropping as we go. So, as we can see, the F prime of t, therefore, is negative, because I'm talking about the change in temperature. Maybe it's 60 degrees, and after 5 minutes, it's 40 degrees, or whatever it is, okay? It's dropping by a certain amount. So, I can say that the F prime of t is less than 0, or the F prime of t is negative. Nice and straightforward. And then finally, the units. Okay, really important here. Okay, as I've said, the units for F prime of t. Remember, we're talking about the drop in temperature with respect to time. We're talking about how the temperature changes after a certain amount of time. So I have a little graph drawn here, and what I wanted to do, we can imagine if we start off with a temperature of 80 degrees, let's say, and we've got 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes, let's say, okay? You can imagine, at the very start, once I take the bread out of the oven, would be up here. After 1 minute, it might drop a little bit. After 2 minutes, it drops again. After 3 minutes, it drops again, okay? Whatever it might be, all right? So you can see that the graph is going to shape in a downward curve, or it might be a straight line, I don't really know, but this is the idea of what's happening. The temperature is dropping as time is increasing, okay? So the temperature is going down while the time is going up. So that's why we see this negatively sloped shape on the graph, okay? And our unit is degrees per minute. Usually we'll put minutes at the end, and I've mentioned that in the next question. But degrees per minute, because I'm looking at the change in temperature with respect to time. Okay, that's question 1 done. Question 2 then, very similar, but just in a little bit different instance. So again, we're talking about weight of an infant in kilos as a function of its age, okay? So we're talking about the amount of months, or the age of the baby in months, has an effect on its weight, okay? Nice and simple. So as we've said there, it represents the change of weight as the age increases. So if you think about it, when you see a baby growing month on month on month, we would expect the weight of the baby to go up as it gets older. So I'm expecting positive values as I've written there, all right? So again, same idea. I've got my graph drawn. You can imagine after 1 month, 2 months, 3 months, 4 months, we would expect the baby's weight to go up. Okay, and again, it might not be a straight line, it might be a curve or whatever, but I'm just giving you a general idea that over time the graph is going to go upwards, okay? And I'll start like that because they have to have a weight somewhere at the start, alright? So just to give us an idea of what it looks like. First one, would you expect the f prime of m, okay, to be positive or negative? The change in weight with respect to months or age, or we can still go with time, okay? So, as I've said, I would expect positive values. I would expect that value to go up as the months go on. Next one, what does f7 equals 7.65 represent? Look at my function. W equals fm. Weight is a function of the amount of months, okay? So if I fill in 7, that's telling me how many months old the infant is. And then 7.65 represents the weight in kilos, all right? So as I've said there, it tells me that at 7 months of age, the infant weighs that many kilos, because I'm filling in my months and it's giving me a weight value. Finally, what are the units of f prime of m? Same again. I'm looking at something with respect to time, all right? So you can see it's kilograms per month. As the months go on, in this case, the weight is going upwards. So, and again, look at this little aside that I've written for you. Usually with these, we're always talking about time, okay? In a lot of instances, we're mentioning time in some instance. So we normally have the time as the second part of the unit. Think about it like speed, which is happening in the next question. Meters per second, okay? Time is usually at the end, kilometers per hour, whatever it might be. So time is usually the second half of the unit that we're talking about. So whatever else is the other thing that we're measuring, you'd usually put that at the front. Finally, question 3. Now this gets into it very similar to what your guys are going to be trying today. So I wanted to run through one of these as well. You can see a car that's accelerating in a straight line so that its distance from its starting point P. Again, I'm going to draw a quick diagram. I've got a starting point P. The car is travelling in a straight line. I won't draw a car, but we've got a straight line. And we can see that the distance is represented by S in meters. Okay, they use the letter S because that represents displacement for physics as well. So physics students, you will know that that's the unit for displacement, or the amount of space that between a start point and an end point. And again, we're talking about t seconds, so that's happening in t seconds, in t amount of seconds. I know there's a lot of units here, a lot of letters here, but let's not get too bogged down, okay? And the function, okay? So this is the important part. The function is the s of t is equal to t squared, all right? So I'm talking about displacement with respect to time. And I calculate that by getting my time value, and squaring it. Very simple. Okay, so you can see I've written in my units there. We're talking about distance with respect to time. And like I mentioned in the last question, distance with respect to time. Okay, so part 1 asks, find the distance of the car from P after 4 seconds. So I'm at P, and after 4 seconds I want to figure out how far the car has moved. So all I got to do is fill in my T value. So I've got it into here, the S of 4, because I'm talking about 4 seconds. So I fill it in to the formula. 4 squared is equal to 16 meters. 4 times 4 gives me 16 meters from P. So after 4 seconds, the car is 16 meters away from its start point. Exactly the same thing for part 2, but I sub it in 5. So 5 squared is 25 meters from the start point. Okay? So part 1, part 2 are exactly the same. The next one, part 3, it talks about the speed of the car in terms of T. Okay? So we are talking about speed, and it's the change. Okay, so let's think about this. It's the change, it's the difference in the amount of meters that the car has travelled each second. That's it. It's the change of distance with respect to time. And the way I get that is to get my first derivative. So you can see I've got S of T is equal to T squared. So I get the S prime of T, my first derivative. And that gives me 2T, because I bring the square down in front of the letter. So 2T represents the speed. Okay? That is our formula to work out the speed of the car. And part 4 asks us to do that. The speed of the car after 4 seconds. So all I got to do, S prime of 4, fill in my 4 value, and I get my unit. As I said, do not forget that. It's really important. I'm talking about distance with respect to time. So it's meters per second. So hopefully they will help you out. You're going to try a couple more from that exercise. I'll pop it up now. I'll pop up the video and the questions I expect you to get done today. Thank you.